Hello everyone, welcome to the lecture on discrete mathematical structures. In my previous two lecture videos, we discussed about introduction to graph theory, what is graph, types of graphs, what is vertex degree and how to use handshaking property. So in this lecture video, we'll be discussing about problems on bipartite graphs and how to plot the graph in general and the problems on vertex degree and handshaking property. First problem, draw a diagram of the graph G is equal to V comma E in each of the following cases. The first case is V is equal to A comma B comma C comma D and E is equal to AB, AC, AD and CD. So here this V denotes that a vertex set having four vertices A, B, C, D and E denotes an edge set having four edges A, B, AC, AD, CD. The case number 2 having a vertex set with 5 vertices V1, V2, V3, V4, V5 and edge set with 4 wedges, that is V1, V2, V1, V3, V2, V3, V4, V5. Third case having an vertex set with 5 vertices P, Q, R, S, T and edge set with 3 edges PS, QR, QS. Fourth graph having an vertex set with 6 vertices V1, V2, V3, V4, V5, V6 and edge set with 6 edges V1, V4, V1, V6, V4, V6, V3, V2, V3, V5, V2, V5. So now we can plot the graph by joining all the given vertices with a given set of edges. The first graph having a 4 vertices A, B, C, D. So I'll be joining the edges A, B, AC, CD, AD to get a graph. So next the graph number 2 having 5 vertices V1, V2, V3, V4, V5 and joining the edges V1, V2, V2, V3, V1, V3, V5, V4. We can get the graph here. Third graph having 5 vertices with 3 edges. So the vertices are P, Q, R, S, T and edges are PS, SQ, QR and we can observe that here T not having any edges. So these kind of vertices with no edges will be called as an isolated vertex. So next graph number 4 having a 6 vertices V1, V2, V3, V4, V5, V6. So joining all the edges, 6 edges what they have given, that is V1, V4, V1, V6, V6, V4, V2, V5, V2, V3, V3, V5. We'll be getting a graph here. Problem number 2. How many vertices and how many edges are there in a complete bipartite graph K4, 7 and K7, 11? So second one is if the graph KR, 12 having 72 edges, then what is the value of R? So to solve this one, I'll be using the formula for complete bipartite graph. So the complete bipartite graph usually denoted by KR, 7. So usually this KR, 7 will be having R plus 7 vertices and R into 7 edges. So with this condition, I'll be finding the number of vertices and number of edges for the given two graphs K4, 7 and K7, 11. Also, we can find the value of R also with the same formula only. So as I told, like the complete bipartite graph will be having KR, 7 will be having R plus 7 vertices and R into S edges. So therefore, K4, 7 will be having 4 plus 7 is equal to 11 vertices. By replacing R is equal to 4 and S is equal to 7, we'll be getting this equation. And similarly, by multiplying this R into S, I'll be getting 28 edges for the first graph. So in the case 7, 11, with R is equal to 7 and S is equal to 11, I'll be having 18 vertices and 77 edges. Second one, so if the graph KR, 12 having 72 edges. So in general, KR, S will be having R into S times of edges. So I can equate both now. So R into S will be equal to 72. By simplifying this, I'll be having R into 12 is equal to 72. So R will be equal to 72 by 12. So the value of R will be equal to 6. Problem number 3. So from that given two graphs, which is the following is a complete graph. So we can see that the graph A having 4 vertices and 6 edges, and graph B having same thing only 4 vertices with 6 edges. But we can observe that the graph number 1 is not a complete graph, because why means this graph is not a simple graph and no edge is connected between A and C. But in the graph number 2, an edge is connected between each of the vertices. So hence we can conclude like the graph 1 is not a complete graph, but the graph number 2 is a complete graph, because each vertex is connected with at least one edge. But here an AC is not connected with any number of edges. So this is not a complete graph, this is a complete graph. Same thing explained here also in this slide also. Problem number 4, find the degree of the vertex, degree sequence, degree of the graph for the given figure here. So the graph having 4 vertices with some set of edges, multiple edges and loops. So like how to find the vertex degree in the sense, the number of edges is connected at a particular vertex will be equal to the degree of the vertex. For example, at the vertex v1, 3 edges are connected here, so the degree of v1 is equal to 3. And at vertex v2, we'll be having 4 edges, so the degree of v2 is equal to 4. At vertex v4, we are having 3 edges, so the degree of v4 is equal to 3 here. But in the case of v3, the loop having, so while counting the degree of the vertex, this loop has to be counted twice. So therefore, the degree of v3 also is equal to 4 here. So as I explained, the degree of will be equal to, degree of v1 is equal to 3, degree of v2 is equal to 4, degree of v3 is equal to 4, degree of v4 is equal to 3. So now the degree of sequence is given by arranging these degrees in non-decreasing order. So we'll be having the degree of sequence is equal to 3, 3, 4, 4, and the degree of graph is given by 3. So the degree of graph can be obtained by taking the minimum degree of the given graph. So in the given graph, the minimum degree is given by 3 here. So the degree of graph will be equal to 3. Next example. So from the graph shown below indicates the degree of each vertex and verify handshaking property. So this graph having 8 vertices, some set of edges, right? So now the degree of at A we are having loop and one edge. So the degree of A is equal to 3 here. Degree of C is equal to 3. Degree of B is equal to 2, degree of D is equal to 2, degree of F is equal to 2, degree of G is equal to 2, degree of H is equal to 1, degree of E is equal to 0, because this is an isolated vertex. So now, to check the handshaking property, the handshaking property is given by sum of each degree of the vertices will be equal to 2 times of the edges. So the given graph containing 8 edges here. So 8 edges. So now the first thing is I am going to add all the degrees of each vertices. So adding this 3 plus 2 plus 4 plus 2 plus 1 plus 2 plus 2 is equal to, will be having 16. Therefore the sum of degree of vertices will be equal to 16. I can split this 16 as 2 into 8. So this 8 is nothing but the number of edges of the given graph. So therefore the equation, the sum of degree of vertices will be equal to twice the number of edges is verified here. So therefore the handshaking property can be applicable for the given graph. One more example, if a graph with n vertices and m edges is a k regular graph, so show that m is equal to kn by 2. So does there exists a cubic graph with 11 vertices, and the next condition is does there exists a 4 regular graph with 15 edges and 10 edges. So we'll verify this one first. The first one is we have to show that m is equal to nk by 2. To prove this, I'll be taking a graph G and it is a k regular graph. So obviously the degree of each k, the degree of each vertex of the k regular graph will be equal to k. Therefore since G having an n vertices and m edges, so we'll be having the degree of all the vertices will be equal to nk. I mean adding the degree of all the vertices of a k regular graph will be having nk is the degree of we'll be getting. So now by using handshaking property, the sum of degrees will be equal to twice the number of edges. So with this condition, I can equate nk is equal to twice the number of edges. So therefore the value of m will be equal to nk by 2. So the next condition is if there is a cubic or 3 regular graph, so then the value of k is equal to 3 with n is equal to 11 vertices. So now I'll be replacing k is equal to 3 and n is equal to 11 in this formula to find the number of vertices. to find the number of edges. So therefore m is equal to, I'll be getting 1 by 2 into 3n. So it will be equal to 1 by 2 into 11 into 3. So it will be equal to 33 by 2. But this graph is not possible because this 33 by 2 is not a whole number. So we can't plot a graph with these edges, right? So we can't plot a graph with n is equal to 11 vertices for the cubic graph. Similarly, the next condition is a 4 regular graph with 15 edges. So in the equation, I'll be replacing k is equal to 4 and m is equal to 15. I'll be getting n is equal to 30 by 4. So, and same thing here also, this 30 by 4 is not a whole number. So hence we cannot plot a graph with this 30 by 4 times of vertices. And the next condition having a 4 regular graph with m is equal to 10 edges. So I'll be replacing k is equal to 4 and m is equal to 10 in the formula. I'll be having n is equal to 5 vertices. So it is obviously true, we can plot a graph with 5 vertices and 10 edges, and this graph is given here, a 5 vertices and 10 edges. So this graph is nothing but K5 graph, or we can call this graph as an Kutrowski's first graph. Thank you.